So coming to next topic, pile foundation. In pile foundation we have two different types of question. One will be designing of pile cap and one will be designing of the pile itself. Pile cap is nothing but pile cap consists of two piles resting on the pile cap itself, and then on top of it will be our superstructure. Here's a diagram. The pile cap will be resting on the piles, these will be rested on the ground, and this is our column. Reinforcement will be provided for the pile cap. So here we have a question to design a pile cap. Design a pile cap covering two piles which are 2 meters apart, center to center. The distance between two piles is given. The size of each pile is 300 mm by 300 mm, and the size of column is 400 by 400 mm, which carries a load of 600 kN at the center of pile cap. The position of column is given to us, which is at the center. We use M20 grade and Fe500 steel. So this is the data we have, that two piles have 2 meter distance center to center in X direction. In Y direction we do not have anything, we just know that the size of pile cap is 0.3 meters. So we are assuming distance from left, and that is in X direction, and in Y direction a distance of 0.5 meters. This gap from the face of the pile on both the sides. From this face of the pile 0.5 meter, and from this face downwards 0.5. Similarly on the other pile. So this will give us the dimensions of our pile cap. So here in Y direction we know that the height of pile cap in this Y direction of pile cap is 0.3 meters, and this is 0.5 and this is 0.5. So total will be 1.3 meters. Similarly in X direction we know that this distance is 2 meters. So here we have 0.5 meters plus half of the pile cap, and 0.5 meter here plus half of the pile cap. So it is 1.3 meters. So total will be 1.3 plus 2 meters will be 3.3 meters. So our size of the pile cap is 1.3 by 3.3 meters. Now the thickness we can assume anything between the effective length by 3 to effective length by 4. So we are taking effective length by 3. Our effective length is center distance between the two pile caps 2000 meter by 3, and we are going to round it up to 750 mm. So this is our depth of our pile cap, that is capital D. To calculate small d we have to remove effective cover for a pile cap is 60 mm, and assume some diameter of bar 25 mm, and half of it will be removed. So our small d is equal to 67.5 mm. Now calculating the loads acting on our pile cap. Firstly, self weight. This is the depth of our pile cap, this is the Y directional length, and then we are considering 1 meter length of pile cap. 25 is the density of our concrete, and 1.5 is the factor of safety. This will give us the factored self weight of our pile cap. And the next is the load from the column, that is 600 kilonewton is acting on our column. We are going to factor it, so that is 900 kilonewton. So this, as you can see in this diagram, this 900 kilonewton is nothing but our column, and these two upward arrows are our piles. This is our pile cap. So this is A column and this is B column. So first we have to calculate reactions, and as you can see we have some overhanging cantilever part, and here we have some simply supported part. So similarly we will be calculating bending moment for these two portions, two different type of portions. Firstly we will be calculating the reactions, and here we have RA, this pile as RA and this as RB. RA plus RB minus 900 kilonewton minus 36.56. This UDL runs throughout the length, so minus 36.36 into total length, that is 3.3 meters. This will give us since this diagram, since this is symmetrical, so we'll get RA plus RB as 1020.65 kilonewton. That is, RA and RB will be same value since it is symmetrical. If it is not symmetrical, then we will have to calculate moment about A or moment about B, then we'll get both the reactions, not a big problem. We got RA as 510.3 kilonewton and RB as same value. So here we have calculating bending moment for cantilever portion, that is WL square by 2. W is 36.56 into length 0.65 meter. Remember our length for the cantilever portion is 0.65, that is 0.5 meter is the extra distance which we took, and 0.15 is the center to center distance of the pile cap, since we are taking from pile cap, center of the pile cap. And so we got this value as 7.72 kilonewton meter. This is our cantilever bending moment. Now for our simply supported bending moment, simply supported portion of the bending moment, we have to calculate bending moment at the center of the point. So here we are calculating the bending moment at the center of the point. Calculating, let us say we are calculating from left till the center. We can go on either ways because it's symmetrical. So 36.56 UDL into 1.65. This is the cantilever. We are assuming this as cantilever portion. This is 36.56 into 1.65 square by 2, WL square by 2. This is the cantilever part removed, and minus 510, that is reaction. This UDL is acting downwards and our reaction is acting upwards, so that's why there is difference in sign. So minus 510.32 is nothing but RA. This will give us 460.55 kilonewton. This is our bending moment at the center of the pile cap. Coming to shear force, for the cantilever portion, we know the formula W into L. 36.56 into length 0.65. This will give us some value 23.76. As we know, the reaction is 510. So from 23.76, this value will go to 510 minus 23.76, that is some 486.55 kilonewton. From 23.76, this is in negative. From 23.76, it will go to 510, like minus 23.76 plus 510.32 will give us this value. And at the center, we know that there's a 900 kilonewton load acting on it. So from 486, it comes slowly down to 450, and then from positive 452 it goes suddenly down to minus 450. Here we can see a 900 kilonewton change. That is basically our column load acting. So if we total it, here there is 900 kilonewton shear force change, and from minus 450 it changes down to 486 slowly, and then as we have a reaction, RB 510 is added, that will give us 23.76 kilonewton shear force at B point, and then 0 at the supports. So here from these two diagrams we got the data that maximum bending moment is 460.55, for which we have to design, and maximum shear force is 486.66 kilonewton. Calculating AST. So to calculate AST we need MU lim. Since we are providing FE as 500 Newton per mm square, our formula is this for MU lim, 0.133 FCK BT square. This will give us MU lim greater than our maximum bending moment. So it is safe, and we have to provide a singly reinforced beam here. Since this is safe, if it was not safe, then we will have to provide doubly reinforced beam, because MU is less than MU. So here AST is equal to 0.5 FCK by Fy. Using this formula we'll get AST as 1640. Using this AST will calculate number of bars. Let us say we are providing 25 mm bars. So AST by pi by 4 into 25 square will give us some 4 bars. So we have to provide 4 bars of 25 mm square. Now we have to choose shear check. Shear check is done at critical section at D from face of the pile. we have to from the face of the pile till a d distance, small d distance. Let us see what our small d value is. Small d is 677.5 meters, that is 0.677 meters. So if you see this figure, this is the center part of our pile cap, where we got the shear force as 450, and this is the support part, like there is 1 meter distance between them, and this is a support at RA, which we got shear force as 486.56 kilonewton. So basically we need to know the shear force at this point, at this midpoint, because here this was our support. If you remember, this is RA, and RA is basically a pile. So as we are taking critical section from d distance from the face of the pile, so face of the pile means this is the center of the pile. So face of the pile is 0.15 meter, that is half of the pile distance, that is 0.15 plus d distance, that is 0.677 meters. So this value is 0.822 meters. So we are calculating 8.822 meters. We have data for 1 meter difference. So using this formula, like from using similar triangle method, we'll get the shear force at 0.822 meter, that is we got this value 468.2 kilonewton. This is basically shear force difference between these two and length difference. So we got this as 468.2 kilonewton at this length. Now we'll calculate tau v value, Vu by Bd. The shear force which we got here will be used, and Bd, we know the breadth of our pile cap 1.3 meters, that is y direction, and d is small d is 677.5 mm. So from this we got as tau v as 0.53 newton per mm square. Now we have to calculate percentage of steel, that is 100 as by Bd. So 100 into as is AST, 4 bars provided of pi 25 mm diameter square, so that's why this formula, and divided by Bd. B into D will give us 0.22 percentage. Using this value in table 19, we get tau c as 0.32 newton per mm square. Now we have to check if this much, how much shear force does our tau c provide. We just check tau v minus tau c into Bd. This will give us the difference in shear, that is basically VUS value, how much more shear we have to provide furthermore. So this so we got this value as 176.15 kilonewton. This is a more shear which we have to accommodate by means of shear reinforcement. So we are providing 8 mm diameter stirrups, and we need to calculate spacing for it. So this is a spacing formula, and which requires the Vu value. Here the shear force is the amount of shear force which we have to accommodate, which we have to extra consider, like this tau c into Bd will give us the value which our which our pile cap will take, but little more has to be done by the reinforcement. So that's why we are providing stirrups. This formula we get the spacing as 168 mm center to center. We round it down to 150 mm. We are providing 8 mm stirrups at 150 mm center to center. This is a rough diagram of pile cap. These are piles and this is our column, and this is the secondary reinforcement here, and as you can see, these vertical lines are our stirrups, 8 mm diameter stirrups of 150 mm center to center, and here we have provided in the main pile cap we got as 4 bars of 25 mm diameter, and here in secondary reinforcement this calculation is generally not done, but we just simply provide 6 bars of 12 mm bars. This you don't need to mention it, but if you can guess any value, checking, like just looking at our main reinforcement, 4 bars of 25 mm bar, this is like second in lateral direction, So this secondary reinforcement can be mentioned. Let's fall for design of pile cap. There is a small problem for pile cap in this PDF. This PDF will be, the link to download this PDF will be in the video.